Now we want to look at the angle between two vectors. The angle between two non-zero vectors is the angle theta between 0 and pi, between their respective standard position vectors. If the vectors aren't in standard position, then move them appropriately. We've found the angle between the vector and the x-axis. Now we'll find the angle between two vectors. The vector can be found using the dot product. Notice the definition. If theta is the angle, then the cosine of theta is the dot product of u and v divided by the product of the magnitudes. All right, let's try some examples. Let's find the angle between the vectors 3, 6 and -4, 5. All right. So the first thing we have to do is find the dot product of 3, 6 and -4, 5, which turns out to be 18. Then we need to find the magnitude of each of those. In this case, for 3, 6, it's the square root of 45. From -4, 5, it is the square root of 41. So the cosine of 18 is the square root of 45 divided by the square root of 41. Use your calculator and find the inverse cosine, which is 65.2. Now, this expression can be written as the dot product equals the product of the magnitudes times the cosine of theta. This form shows that u dot v and the cosine of theta have the same sign. There are 5 possible orientations of two vectors. They can be in opposite directions. We can have an obtuse angle. We can have a 90-degree angle, an acute angle, and then be in the same direction. Do you notice here that to have a 90-degree angle, the dot product must be 0? Look at the third orientation. They are known as orthogonal vectors. The vectors u and v are orthogonal if and only if the dot product is 0. It is convenient to extend the definition of orthogonal to include the 0 vector. Let's determine whether certain vectors are orthogonal. All right, let's suppose that I have u equal to 1/4 of 3i minus j, which of course we know would be 3/4 minus 1/4. 5i plus 6j is the vector 5, 6. All right, the dot product of u and v would be 3/4 times 5 plus minus 1/4 times 6. 15/4 minus 6/4 would be 9/4, does not equal 0. So those two vectors are not orthogonal. All right, let's try another one. How about one of the standard vectors? U equal to I, which is 1, 0, v equal to minus 2i plus 2j, or minus 2, 2. Let's find this dot product, which is minus 2, does not equal 0. So those are not orthogonal either.